All right, so I want to get down to business on the last little bits of cancer, because there's a bunch of interesting things here that we can now explain given what we know. Like I said, you cannot inherit a tumor, because if your zygote was actually had improper growth control, you would never develop properly as a person. So you can, however, you can inherit an increased risk of cancer, and that actually happens in many different ways. One of which I want to talk about now, like I said, because we can explain it very easily. So I say there's many. Here's one. So some people are born with one copy of p53 gene mutated. Right? If you remember what we said last time, p53 is a gene, produces a protein that prevents cell division. If you could make all the p53 in a cell go away, that cell is going to divide. So one of the ways is through the normal growth factor and RAS and all that. Another way is if you have mutations in both copies of the p53 gene, neither one makes p53, no p53, cell division proteins get made and your cell divides. Some people are born with one copy mutated. Those people start off normal, however, so they're born like this. So if you have your p53 genes, you have two copies, one from mom, one from dad, and say you start off with one copy mutated in all cells. These people have what's called Li-Fraumeni cancer syndrome. That is, they get cancers, let me write that more clearly, cancers early in life and in many different places in the body. And they have a much higher risk of cancer than people born with two normal p53 genes. So let me draw a diagram of that for a second. So this is a particularly, it's quite rare, but particularly nasty genetic disease. These people, again, are not born with tumors, but they typically develop tumors very early in life, like when they're 1 or 2 or 3 years old. And they typically develop tumors in many places in their bodies. And they typically live only a very few years because there's so many cancers that there's only so many you can treat. It ends up, they end up dying from cancer at quite a young age because of their risk is so much higher. So what I want to show you now is why, and we can explain why their risk is so much higher. So here goes. So why is the risk, so why higher risk? And the answer is you look at their p53 genes. And so here's a normal person. All their cells start like this. So everybody in this room, because I know nobody in this room has Li-Fraumeni syndrome, because if you did, you wouldn't be here. They are all normal. 2 copies of the p53 gene. In any one of us, if you have one mutation in p53, then you end up with, as I showed yesterday, 1 mutant copy. These people, and all of us probably have the situation in many of our cells, this is still normal. Why is that? Because doing something is dominant to not. What does p53 do? It prevents the cell from dividing. So the bad copy is making a protein that does nothing. The bottom copy, on the other hand, is still good. Producing p53 is shutting off gene expression except when it's expressly needed. And so as a result, these cells are normal. And for sure, everyone in this room has many cells in their body that are in this state. They're totally normal. They have one mutation in p53, but they're not, it's not a problem unless you get a mutation in the next copy. Basically, this copy still makes enough p53 to prevent cancer. If, however, we have another mutation in the other p53, then you end up with the situation that leads to cancer, which I talked about last time. So this top row is sort of a review. If you have mutations in both, there's no p53 that leads to a tumor. And this guy takes two mutations, which is why most of us don't have cancer, because the chance of two mutations in the same gene, the two copies of the same gene in the same cell is pretty unlikely. So I might have one mutation in the cell over here and a mutation in the cell over here, but the chance of it happening in the same cell is pretty low. So that's why cancer takes a long time to develop. It takes a long time for that coincidence to happen where you end up with two mutations in p53 in the same cell. All right. Questions about that before we talk about the leaf from any people? Okay. So what happens in the case of leaf from many is that all their cells start one step ahead. They all start, they're born like this, with one broken copy, with their backup broken. So all they need, all they need is one mutation in the other p53, and they're going to end up with a tumor, with both copies mutated, and as a result, this leads to a tumor. And this one here takes only one mutation. Therefore, much more likely. And so the idea is this. It's relatively easy by mutation to break a gene. We've done a zillion problems like that. You know, you hit the start codon, you make a missense mutation, messes up the protein, you make a nonsense mutation, you mess up splicing, you mess up the promoter. There's a zillion ways you can break a gene. So p53 is a big, fat, juicy target for mutations that can give you cancer. But again, every one of us in this room has a backup copy. So if I blow out one copy in this cell, it doesn't matter. I've still got another copy of p53 to cover for me. However, the leaf from many people are born without a backup. So one hit in that one surviving copy of p53, and that's on its way to making a tumor. And so and since one mutation is much more likely than two, these people have a much, bless you, I think, I hope that's what that was. Lost my train of thought. So one mutation is much more likely than two. So these people without a backup copy are much more likely to develop cancer. They develop cancer at a young age and typically don't live particularly long. Questions about what's going on here and what that means and how you would explain that given the way we know how p53 works? Yeah? So can the patient live a normal life with this condition until a mutation occurs? The answer is yes. The trouble is there's the chances of mutation, since there's so many cells in your body, it won't be long before. Basically, you know, you're rolling a million-sided or a 10 billion-sided dice, but you're rolling it so many times, it's going to come up with that black spot once in a while. And so it doesn't take long before that happens. So it's typically within their first few years of life they get cancer. Other questions?